Hey, everybody. Really interesting chat today as we talk about the role of AI when it comes to developer velocity and software development in general. So much going on here. We have a true innovator and expert with us. Peter from CodeMetal, how are you?
Great. Thanks for having me, Evan. Excited to be here.
Well, really excited to chat. This is an area that's generated so much enthusiasm and interest. Before that, maybe introduce yourself, your journey, and what was the big idea behind CodeMetal.ai?
Yeah, my name's Peter Morales. I'm the CEO of CodeMetal. I started out my career with a degree in physics and started really wanting to go into industry more than academia, and mostly because I loved coding. I got to watch a lot of the fundamental things that we were researching come to life. And defense was actually a really cool area where I got to apply that. So you get to do first principles, but then actually build some code out of it. And went over to BAE Systems in Burlington. I'm in our office in Boston, so not too far from here, and started working on different RF and EW systems. So those are radar systems and electronic warfare. And part of the work that we did there was basically taking high level ideas, so things that we would write in MATLAB, or if you're familiar with Python, popular for AI, and bring that down to code that would actually run on hardware. So those could be FPGAs, those could be GPUs, those could be small embedded devices. And the thing that we did really well was we actually automated a lot of the work that
Mm.
could be automated. So we actually generated unit tests, we generated data for those unit tests, all from this high level code, which really made our lives easy. We would basically take then the concepts at the high level and map those down into different hardware ways of thinking. And so that was the task of basically bringing AI to the edge, or different sort of signal processing algorithms to the edge. And we got to work on systems that ran on the F-35, systems that ran in the National Capital Region, a whole bunch of really cool work. That actually, the F-35 work in particular got me excited about AI. It was one of the first reasoning systems that actually ran on that airframe. And it was sort of, hey, this is code that can think. And that's when DeepMind had also published their Q-learning paper, and that made me want to kind of go all in on AI research. And colleagues recommended I go to MIT Lincoln Labs, so I could take courses at MIT there, could work on different AI projects, and I ended up moving over there. And so over at MIT Lincoln Labs, focused on AI research with some great colleagues at Stanford, focused on computer vision projects locally in the counter UAS domain. And, again, it was the same sort of idea where you're working in a high level language to do the research, maybe a small team. And then it takes a big sort of group of software developers and, sometimes low level hardware engineers to bring that into an actual product.
Mm.
And we worked on deploying different prototype systems that protect the DC airspace from drone attacks. And that worked because the lab at the time was looking to do more AI research. They farmed an AI group out of the CTO's office, and I got to be one of the founding members there. So it was a really cool opportunity to work with campus on Air Force problems that the Air Force wanted us to work on. And so worked with like Dava Newman before she became head of Media Lab over at MIT there. Got to work with some of the different staff there on really interesting problems. But it was a little bit more of a paper writing exercise, and I love to build. And Microsoft was doing the HoloLens. And so I ended up leaving the lab after that, moving out to Washington to work on that device. And I think the big thing and really the inspiration for CodeMetal was when I was going over to Microsoft, had this expectation that us getting our algorithms to edge was going to be really different. I was in defense, which maybe doesn't always get the credit for software engineering. And then I was at the lab, which definitely didn't have the software engineering chops. And so I thought the actual bringing these algorithms down to hardware, whether it be a robot or some medical device or anything, was going to be a lot easier, specifically on the HoloLens. And it wasn't, even though they make their own chips. It was the exact same. In fact, I still give kudos to the BAE group there, Alpha Tech guys, that they're probably the best that there were at bringing these algorithms to edge. And it was the same very stressful process to get these things running on hardware. And that was really the motivation for what we're doing, that like, if this exists in every industry, bringing a hardware product, tackling all the different low-level SDKs and firmware issues, that there's a really good spot for automation here and sort of filling in a gap that right now real-time system developers do with some tools, and specifically AI tools. And so we came up with the idea of essentially integrating large language models with formal methods and testing and other sort of traditional code techniques to right now. And I think vibe coding is kind of like the hot thing that everybody's talking about. Imagine now being able to actually trust the code that comes out of that. So generating tests, generating different sort of proofs that basically show that your intent was carried out the way you wanted it to. And that's our focus at CodeMetal, essentially automating a lot of the nitty-gritty processes that can be automated with full sort of autopilots rather than copilots.
Brilliant. I love the mission. So big picture AI copilots, if we can call them that, no offense to Microsoft, but just generally are becoming very widely used across all kinds of developer environments. So how do you see yourself on this landscape vis-a-vis the current wave of copilots and other LLM-based dev tools?
Yeah, so you can think about the copilots as really doing two things well. So they're positioned for clean sheet problems, meaning like I don't
Mm.
have any code laid down, but I want to generate, let's say, like a rough prototype. And I think they're great for that. I think they're a really awesome tool for that clean sheet problem. You can spin up, I mean, basically, you see a bunch of people like making tiny little projects like, oh, look how quickly I got a kind of working thing. Or maybe it works to their intent all the way. I think where we fit in is if you look at like sort of a production chain, like an actual, the giant teams that are sort of operating from companies like Toyota and automotive to, L3Harris is actually a customer of ours in defense.
Mm.
Um, these require a lot of different expertise, meaning like they need the folks to maybe write the initial clean sheet problem, get the feature that they want, but now it gets handed off to somebody that understands real-time system development, which might get handed off to somebody that knows hardware. For example, in their use case, they actually do signal processing algorithms in MATLAB, move it to C++ because it's like a real-time language that they can kind of wrap their head around how it would get deployed, and then actually do another copy to VHDL, which is the actual FPGA programming language that runs it. So that whole process is actually something that is happening all over the place. And so being able to validate from the starting point, sort of the initial code that you write, using that as a reference, we can actually give sort of a provable output that's optimal for the hardware that you're targeting. And so that speeds up development times in a huge way. So where we fit in the pipeline is sort of, use a copilot to sort of help you be 20% faster, whatever, get the clean sheet out quicker, but it's not posed from an AI perspective in the same type of way that we pose our AI problem, which is given some known good, how do I work my way to a certain target language and imbue it with expert knowledge on the hardware?
Got it. So let's talk LLMs. I mean, it's amazing. The improvements are fast and furious, but there are still trust and explainability challenges, as you know better than I. So how do you think about transparency and traceability and, them making code level suggestions and those sort of issues?
Yeah. So it's really interesting from, again, if you're pairing it with ideally an expert, right? I think if you've ever looked at some of the studies, somebody who knows how to prompt these things well can actually get very good productivity gains. So, I think that's an important aspect of it. These are only as good as the questions that you ask them. A lot of the sort of co-pilots right now are focused on auto completion. That's sort of the learning task I referred to earlier. That's their problem, meaning they're trying to predict what you want to do. You're trying to kind of look over your shoulder as like a pair programming eyes and save you time that way. What we're posing this as is essentially I've implemented something in, it could be pseudocode, it could be, an actual implementation in Python and MATLAB, which we think is fine to write, which you could have used an LLM to write. And we want to use that as a starting point. And now for traceability and for, trust reasons, we're going to generate a whole bunch of artifacts as we port that over to the software that's actually going to run in production. And now you're going to be able to actually, for your compliance needs, track the code that you're actually running in production and all the sort of derivative software projects and have unit tests, test harnesses that actually show that it matches the initial code, all the type of things you need to build that trust into the system. So I think right now there's a little bit of gap between, let's say, the LLMs and getting to that point, in that, like, sure, I've generated the code, but how am I going to trust what came out of it? We're starting at the point of I have something I trust and I've created, but I've created it in a really sort of efficient way for prototype development, feature development. So high level languages like Python or MATLAB. And now I want to go from there to the target. So I think that's where we sort of differentiate. I think the problems with LLMs today are going to be, I'm sure a lot of CIOs and CSOs are freaking out thinking about all the sort of things being dumped into code bases and put into production.
Well, that's a great point. So let's talk data. I mean, how do you think about secure integration with customer code bases and repositories? And you have all this DoD experience, so you understand how sensitive enterprise or IP can be. What's your sort of philosophy there?
So I think a lot of these companies, they either have to get there in the trust level where they can
Mm,
have somebody actually own their data. But a lot of, I think, companies are moving to running on-prem GPTs or code models, especially you look at like DeepSeek popping up, being fully open source, and sort of making companies question, should we just host this all and give the capability internally, to our employees to be able to have a GPT-like capability trained on our own data rather than serve it up to, especially, the cloud hosted solution. So for us, a lot of our customers want to be able to run everything that we do on prem. And we
mm,
support that with deployments on prem.
fantastic. And so how do you work across different enterprise sizes? You mentioned, small nimble teams, and you got big defense contractors and enterprises. How do you see that working across different cultures and organizations?
Yeah, so I think a lot of the shift in moving to AI tooling is actually more of a cultural shift
Mm,
than sometimes even technology. It's interesting as you can imagine us that are proposing, hey, right now you do a process that takes 12 months, we can give you with guarantees kind of the same code, let's say 80%, in a month. I think that
mm.
becomes like something that requires a lot of sort of rethinking of how they organize their
Wow.
organization. So I'm really curious and sort of intently watching how all these companies react to the jump in sort of AI technology. I think right now we're at the point we were talking about LLMs earlier, where like you can do some neat things, but like once people start specializing these tools and building them into workflows where let's say the scaffolding for it really ties into their existing processes, that's where you're going to see these huge productivity gains. And that's where pretty much organizationally people are going to have to rethink how they build things.
Wow, that's a huge discussion, maybe a different time. In the meantime, let's talk impact. Any examples or anecdotes or stories you can tell on,
Yeah.
on where
So
CodeMetal is helping with that velocity?
yeah, publicly, I can talk about one of the teams we're working with, on FPGA development. So
Mm,
they're looking at processes from 6 to 12 months, and right now this is cutting them down about 50%. And
wow.
so right now it's not fully automated, meaning like there are bits where the sort of person needs to come in, but we're working closely with our partners at L3 Harris and other companies like that, that play with FPGAs at essentially giving them the trust and sort of verification outputs that let them sort of hand off more and more to the AI tooling.
Fantastic. And where do you see the product, CodeMetal, your team going in 2 to 3 years? Everything's moving so quickly. How do you stay ahead of the curve and not
Yeah,
get disrupted by the same tools you're using?
yeah, it's interesting. I think really it's being opinionated about where we're going, and so I think we have strong
Mm,
confidence in the sort of verification bits and the validation, and we invest in the things that maybe are completely additive, meaning like we're not necessarily trying to train a giant LLM and run in that direction. We're leveraging, the current state of the art in our pipeline, and everything's additive to those tools. So, we don't feel we're necessarily going to race with OpenAI or any of the folks building the code models. We want to basically scale with them. So as those models get better, our tool runs faster, gives the result quicker. Right now, it takes quite a bit of time to generate a complex, let's say, target, meaning going from like a high level to a very complex hardware target. As the models
mm.
get better, that's going to speed things up. But yeah, I think I would say the organizations, targeting sort of a time horizon of tech that's coming online in the next year, and sort of that sweet spot of like, let's always be looking ahead and pushing towards that 1 year out, where we're not so far that we're a pure research org, and we're not so close where we're going to get gobbled up by the next iteration of an AI tool.
Yeah, great challenge there. And any advice for early stage founders, entrepreneurs, maybe folks in academia, trying to build out AI first products? You've been through
Yeah,
it now, so what advice would you give them?
I think if you're an entrepreneur, leverage your value prop from what do you have that other people don't. So, our
Mm,
focus is the integration of compiler technology and formal methods, right? And so we're leaning on the AI explosion. We've got great people from OpenAI and other places at the company helping with the
Good.
AI side, but what we're really doubling down on are the things that make us different. So if I could generate code that I guarantee certain like pain in the butt, even for like a manual developer, compliance needs to be met. That's a huge value prop, and that's a huge differentiator that we're saying, hey, our code actually meets these compliance standards and has a proof, that you can't get from an LLM that sort of, relies on randomness. So yeah, if you're an entrepreneur, I think lean on the things that make you different. Those are the things that make you stand out from the rest of the crowd. And if you're in academia, um, from my days working at MIT, I think I got to imagine a lot of students are feeling scooped all the time with how much craziness is going on. So again, I love labs with like great North Stars, meaning they've got like something far in the distance that they're trying to target. And I think looking for those labs that are trying to do something different from everybody and not just figuring out what's the plus one, but what's the like 10 years out, do a better job at staying relevant.
Great advice. What about you and the team? What are you up to over the next few weeks, months? Any travel,
Yeah.
events,
Well,
talks? What's on your radar?
yeah, so this year we did CES, which was great for us. We're heading
Oh,
out
wow.
to an automotive event in Detroit. Forgive me, it's escaping right now the name of it. So we'll be out there in a couple of weeks. We've just got a new hire we're going to announce. We're super excited about helping us on the growth side. But yeah, lots going on from the growth side. Lots going on from where you can see us in public. And yeah, if you're interested in the stuff I'm talking about, feel free to hit me an email. And we are always hiring.
Well, that's good news. So thanks so much for sharing the vision. And we'll have to grab a beer at some point here in the Boston area. Peter, thanks for joining, sharing the vision and mission.
Yeah, thanks, Evan, for having me, and great to meet you.
Likewise, thanks everyone for watching and sharing. Take care.